bottom of page 16. We're keeping going. This is 4 out of 5 on day 2. We're still doing our parent function notes. Let's get to it. All right. Bottom of page 5. One thing before we do anything else. Hey, look, I wrote a page number on there. Actually, let's write the function first. Is this log base 2? Gosh, I hope so. I legitimately can't tell. Actually, I think this is log base 10. Okay. This is the logarithmic. And yes, I used a funky L on that one. There's a reason for it, but that's a cursive L. That one is y equals, and then log. That really should be, I'm guessing 10. Yeah, that makes sense. Log base 10 to the x. Again, this is a weird function. Why do you think I call these the exotics? They're weird. Like, how many of y'all have even seen anything that looks like this? Okay, this one's a little weird. And actually, before I get into anything else, this one gets mistaken for the square root so often. It's ridiculous, okay? What's really happening here, it like looks like, and I mean, granted, I will totally give it to you, this looks a lot like the square root function above here, okay? They look really similar. But I'm going to draw using the pen. Hopefully this works out. Okay, so you can see, like there, our arrow's going to the right. Like, yeah, square root function, coach. Like, come on now. But here's what it does. Instead of like ending, like stopping like the square root one does, it actually technically keeps going. It gets really, 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 really close. It gets really, 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 really close. And, you know, hopefully I didn't just butcher this, but it gets super close to that y-axis, but it never actually touches it. Okay, so this is actually another one with an asymptote here. Okay, what happens is this one actually has a barrier that's vertical now, or up and down. Okay, so we actually do have an asymptote on this one too. Okay, this one's just, it's a vertical asymptote, so it kind of stops it like that. Okay, let's talk about some points here. If we have, say, if we talk about x is 0. Talk about x is 0 for a second. Something interesting happens. It's not, meaning like nothing, like literally. What was I gonna say? Like literally nothing happens. Like legitimately, like it's undefined. Like, you literally can't even put 0 in this function. Like that's kind of the point of the asymptote. Like, so any other negative numbers, like -2, -1, those are going to be undefined. Okay, that barrier holds strong. Nothing for those x's over there. So that's actually, that affects our domain. So let's talk about that. So 0 is that barrier, but it doesn't cross that barrier. It doesn't touch that barrier. So what happens here is it's going to be less than x. We're not going to put the line underneath it because it never actually gets to 0. See, it doesn't actually touch 0 there. Okay, so keep that in mind. All right, so then that makes it 0 to infinity. And again, I'm using the little parentheses rather than bracket because it's not including it. Okay, don't worry about those details. We'll get those details later. Range, though, what's funny about the range here, it's all real numbers. -infinity to infinity. Anything you want, right there. Boom. Okay. It literally, it goes down forever. I mean, it seems like it kind of like flattens out up top, like it's got that flatten out thing. But the further you go, the more it'll go up. So I mean, so yeah, that's kind of the idea. An interesting point we've got going on here is we get to 1 that gets us to y equals 0. Yeah. Let's see, what else do we got going on here? If if I were to pick a point somewhere before this one, and it's actually not even on the graph, I can tell, it wouldn't make any sense. So what we got going on here is if I go all the way up to x equals 10, then what happens is my output, my y equals 1. So it'll finally get up to a y value that makes sense. That would be our next perfect point after 1, 0. Okay, it's weird. It's really flat. Like, again, it's kind of like the square root or cubed root, sort of. That's why I put this in the exotics page. Let's see. Y-intercept. Interesting concept here. There is none. Okay, it's kind of unique in that it doesn't cross the y-axis at all. But it does cross the x-axis at a different kind of point. That is at 1, 0. Okay, that one was right here. Okay, so that one was right there. Asymptote, this one does have an asymptote. Okay, this one, except our asymptote being a vertical line, it doesn't cross the line x equals 0. So our asymptote, our invisible barrier, is x equals 0, making it a vertical line. This one also, since the range is all real numbers, range can be whatever it wants. There's no maximum or minimum. Okay, it just doesn't happen. All right, so there's that one. Again, exotic, weird to type in the calculator. It's possible. Okay, some of you might know how to do it. Again, when we start playing around with it, that's when I'll really show like where are those functions, where can we find them. Okay, these calculators are pretty sweet. So we can take a look at those and hey, that's 4 out of 5. One more to go.